Today we are going to learn about mastering Numpy Array Broadcasting. We'll explore how to efficiently perform operations on arrays of different shapes using Numpy Broadcasting to optimize code performance and reduce memory usage. Welcome to the video on mastering Numpy Array Broadcasting. Broadcasting in Numpy refers to the ability of Numpy to perform arithmetic operations on arrays of different shapes. This concept is crucial for data processing as it allows for efficient computation without the need for extensive memory allocation. In this video, we'll break down what broadcasting is, explore its rules, and examine how it can significantly enhance your data processing tasks. We'll also look at practical examples and common issues you might face. By the end, you'll be equipped with the skills to streamline your workflows using Numpy Broadcasting.
Broadcasting in Numpy operates under specific rules that determine how arrays of different shapes can be used together. The fundamental rule is that dimensions of size 1 can be broadcast to match the dimension size in another array. This means when two arrays are not of the same shape, Numpy will try to broadcast them to a compatible shape. For example, if you have a 3, 1 array and a 1, 4 array, they can be broadcast to a 3, 4 shape. Understanding these rules is essential as it allows you to manipulate arrays without manually reshaping them, saving both time and computational resources. We'll explore these rules in detail and see how they apply to real-world data processing tasks. To effectively use Numpy Broadcasting, it's important to understand which shapes are compatible. Let's consider a few examples. Suppose you have a 2D array of shape 5, 1, and a 1D array of shape 4. When you add these arrays, the 1D array is stretched to 5, 4 to match the 2D array, allowing element-wise operations. Another example involves a 3, 1, 2 array and a 3, 2 array. The second array is reshaped to 3, 1, 2 to align with the first array. These examples illustrate how Numpy intuitively aligns dimensions to perform operations efficiently. Understanding these compatibility patterns will empower you to identify potential broadcasting opportunities in your data processing tasks.
Numpy Broadcasting is particularly useful in performing arithmetic operations on arrays of differing shapes. Consider an example where you have a 2D array representing multiple sets of data points, and you want to normalize each set by subtracting the mean. Broadcasting allows you to subtract a 1D array of means from a 2D array without manually reshaping it. Similarly, if you have a matrix of coefficients and a vector of constants, broadcasting enables efficient multiplication without duplicating data unnecessarily. This significantly reduces code complexity and enhances execution speed. Broadcasting essentially allows you to focus on the logic rather than the mechanics of data alignment, leading to more concise and readable code.
While Numpy Broadcasting is powerful, it can sometimes lead to unexpected results if not used carefully. A common mistake is assuming that all operations will broadcast seamlessly. Errors like operands could not be broadcast together occur when shapes are not compatible. Understanding and interpreting these error messages is crucial. Unintentional broadcasting can also lead to incorrect calculations, especially when dimensions are implicitly aligned. To avoid these pitfalls, always verify the shapes of your arrays before performing operations. Use Numpy's shape attribute to debug issues and ensure your arrays are aligned as expected. By being mindful of these aspects, you can harness the full potential of broadcasting without running into common errors. One of the standout advantages of Numpy Broadcasting is its ability to enhance performance. Broadcasting allows you to perform operations without creating unnecessary copies of data, reducing memory usage significantly. This is particularly beneficial in large-scale data analysis, where memory efficiency is paramount. Additionally, broadcasting streamlines computational tasks by eliminating the need for explicit loops, leading to faster execution times. For instance, operations that typically require nested loops can be performed in a single line, reducing code complexity and enhancing readability. When compared to traditional methods, broadcasting offers a more efficient approach to data processing, making it an invaluable tool for optimizing performance in real-time applications. Numpy Broadcasting is not just a theoretical concept but has significant practical applications in real-world data analysis. In data preprocessing, broadcasting can be used to normalize datasets, scale features, and transform data efficiently. In statistical analysis, it allows for the computation of metrics across different dimensions without manual reshaping. Machine learning pipelines benefit from broadcasting by enabling efficient matrix operations, such as weight updates and gradient calculations. We'll explore case studies where broadcasting was used to accelerate data processing tasks, demonstrating its versatility and effectiveness. Whether you're working with large datasets or complex algorithms, broadcasting provides the tools to simplify and optimize your workflows, making it an essential skill for data scientists and engineers alike. Despite its power, Numpy Broadcasting can sometimes lead to errors that need troubleshooting. A systematic approach is essential for identifying and resolving these issues. Begin by examining error messages to understand the nature of the problem. Numpy provides insightful error messages that can guide you to the source of the issue. Common scenarios include mismatched dimensions or unintended broadcasts. Utilize tools like the PyCharm debugger or Jupyter Notebook's interactive environment to step through your code and inspect array shapes. Adopting best practices, such as consistent array dimension checks and clear documentation, can prevent many broadcasting errors. By mastering these troubleshooting techniques, you'll be able to resolve issues efficiently and maintain robust data processing pipelines. In conclusion, mastering Numpy broadcasting is a fundamental skill for anyone working with data. We've covered the core concepts, explored the rules that govern broadcasting, and demonstrated its applications across various domains. The ability to perform operations on arrays of different shapes without manual reshaping leads to more efficient, readable, and maintainable code. We encourage you to practice using broadcasting in your projects and explore its potential further. With continued learning and application, you'll find that broadcasting becomes an indispensable part of your data processing toolkit, enabling you to tackle complex tasks with ease and confidence.